All right, guys, here we go. 7-1, section 7-1, rigid motion in a plane. Okay, I'm gonna try to film some of these at school. I'm tired of doing them at home. So we'll see how these work out. A little more natural. Down here on a Wednesday in December. I'm trying to finish up the rest of the geometry videos. So we're going to talk about rigid motion in a plane. In this section, we're going to talk about reflections and rotations and translations and all that kind of stuff. It is on the MCAS test, believe it or not. So it is something that's important. Okay, we're getting toward the end of the first curriculum. We may get ahead, but we'll see. So figures, okay, figures can be rotated, reflected, and translated to create new figures. Okay, so you start off with this figure and you either rotate it or you reflect it or you translate it, which means you slide it. You take it and you move it up and over or down and over or something like that. And they create this new image. Okay? So the original is called a pre-image, and your new figure is called an image. Okay, so the original becomes a pre-image and the new figure becomes an image. Okay, and the operation, whether it be a rotation, a reflection, or a translation, those are all called transformations. So that's the mapping of a new figure. And the types, the major types we're going to talk about are rotations, which is actually the hardest of them, reflections, and translations. Okay, so that's the main gist of stuff in this section. Okay, so we're going to look at some examples. Okay, we're going to look at some examples. I'm going to erase some of this stuff. If you need this again, you can rewind the video or pause it and go back. Okay. Beauty of having it on video. So, let's say we had a figure, okay? And this is my pre-image. That's the original. And I want to reflect it over a reflecting line. Okay? So, we're going to talk about reflecting now. So, if it reflects on this side, I'm going to try to gauge this so it's about right. It's not going to be perfect. Okay? Not going to be perfect. Anything with me in drawing is never perfect. But that's the main idea. Okay? So here is your pre-image. Here is your image. The point should line up. This point here should line up with this point here. And this point here should line up with that point. Okay, and so on. So this would be an example of a reflection. Okay, that's an example of a reflection. And then you could have, sometimes they'll say reflection in a line. Okay, they like that terminology. So that's what we use. And then we'll talk about a rotation about a point. Let's say I had that same F, and let's say this is a point, and I want to do a rotation clockwise about that point. Well, we're going to learn how to do it in section 7.3, but this angle would have to be whatever the angle that you're rotating it. But if it was down here like this, that would be an example of a clockwise rotation. This being my pre-image, and this being my image. Okay, and then as I had said, the other type, the other main type that we're going to look at, look at this. I hate this. I just washed it. It's already a mess. The other type, okay, so let's write it. This is a rotation about a point. Okay, and so the last one is going to be just a translation. A translation. Okay, and so here's my original, here is my pre-image, and let's say that the direction said to go over and up, then there's my image. Okay, with a translation, you could take this and you could slide it, okay, and this is your image. So another name for a rotation is a turn. Another name for a reflection is a flip, and another word for a translation is a slide. It kind of describes what's happening there. Okay, it kind of describes what's happening. Just checking my battery power. Looks like I've got enough. Hoping I have enough. If I run out, it'll be a second video. That's all. All right. So we're going to look at an example here. I'm going to pull it up on the overhead so that you guys can see it. Rather than me try to hack it by drawing it, I am going to put it up on the board. Okay? So let me make it a little bit bigger for you. I don't know why the light is doing that strange thing. Normally it's like lit up well. I'm not really sure why it's not. I apologize for that. I'm going to look in the video and make sure that you guys can see that. There's no point in me doing it if you can't see it. Yeah, you guys can see it. All right, so let's see what it says. Let's focus this. There we go. A little better, right? A little better. All right, so it says use the graph of the transformation at the right. Name and describe the transformation. Okay? And they say name the coordinates of the vertices of the image, and then is ABC congruent to its image? Well, let's take a look. We're going to break that down step by step. Okay, so the first thing I want you to do is I want you to look at that and try to speculate, try to make an educated guess, a conjecture from the earlier chapter. Try to look and see what type of a transformation is that. Does this look like it was rotated? Does it look like it's been slid? We've put our fingers on it and we've translated, or we took it and slid it? Or does it look like it's a reflection? I want you guys to think about it, see what you think. So, part A, I look at that and I think that's going to be a reflection, okay? I think that the reflecting line is the y-axis, and this point is here. This is 1, 2, 3, 4 away, 1, 2, 3, 4 away. I think that's the way it's going to match up, okay? So, I am going to say a reflection, okay? And it's a reflection in the y-axis, because the y-axis is the reflecting line, okay? Now it says, name the coordinates of the vertices of the image, okay? Of the image. So the image is the new point, okay? The new points of the new figure. So in this one, if you look and you say, well, how can I tell which one's which? Well, the original, okay, I'm going to write up here the pre-image. The original is A, B, C, okay? And the new figure, the image, is triangle A prime, B prime, and C prime. Okay? So, that's how you know that this one's the new one. It has that little prime symbol. Okay, it's just a little dash, almost like a dash for an exponent. Okay? So that's how you know that that's the image. But that's not what they asked for. They asked for the coordinates of the vertices of the image. So I gotta come up with these coordinates. So I'm gonna do A prime, B prime, and C prime, and they want me to write down the coordinates. So A prime, I go over 1, 2, 3, 4, and up 1, so it looks like that's gonna be 4, 1. And then I look at B prime, over 1, 2, 3, up 1, 2, 3, 4, 5, 3, 5. And the last one, C prime, over 1, up 1. Okay? So, we did part B. Part C. Is ABC congruent to its image? And I don't know that we know enough to really talk about that yet. We're going to talk about this in a minute. Okay? We're going to talk about this in a minute. We talk about what an isometry is. But it looks like it is. It certainly looks like it is. Okay? If I looked and different things that I can kind of gather, the points are the same distance away from my line. 1, 2, 3, 1, 2, 3. Okay? This point is 1 away. This point is 1 away from my reflecting line. 1, 2, 3, 4. 1, 2, 3, 4. A prime, C prime is 1, 2, 3 units. I can count that because it's a horizontal line. 1, 2, 3 units. So it certainly looks like it's congruent. Okay? Well, all right. Well, all right. Okay? Now, we could test that. Okay? We could certainly test it. We wanted to test that to see if it's congruent. Okay? What we would do is we would use the distance formula to show that the sides are congruent. And once you've shown that 3 sides are congruent, you know from chapter 4, you could prove the triangles are congruent by side, side, side. All right? All right. Moving on. Moving on. The next thing is this thing that's an isometry. And I've got the definition on the board. I'm going to write it up here because I don't know that you're going to be able to see that. Isometry. And here you'll be able to see it better. So this is a transformation. Is a transformation that preserves lengths. I'm going to write this out differently, okay? Angle measures. Parallel lines. The distance between points. And I'm going to say this word here. Betweenness. You know, that's a word. Okay, I don't know if it's a word. But they use it in some geometry texts, so I'm going to use that. So what does this mean? Well, it means that an isometry is a transformation that preserves lengths. So the lengths of your pre-image are the same as the lengths of your image. If you take a figure and you rotate it, or you reflect it, or you translate it, the figures will still be congruent. Okay? Their angles will still be the same. If you take a figure and you either reflect it, rotate it, or translate it, it's not going to change your angle measures. If you have parallel lines in your original figure and you transform it, it's still going to be parallel. The distance between points and betweenness. Betweenness is weird, okay? But I'll show you what that means. If I had a segment that was like this, A, B, and I had C in the middle, if I take this segment and I either reflect it, rotate it, or translate it, C will still be between A and B. Okay, that's what that betweenness means. Okay? So this next part says, which of the following transformations appear to be isometries? So we look and we say, geez, does that look like it's the same? Do they look like they're congruent? What do you guys think about number A, or letter A? What do you think about letter A? When I look at that, pre-image, image, kind of looks the same. Looks like it's a reflection, okay? That is about the same as that, okay? I would say that those are congruent. Take a look at B. What do you guys think for B? I don't think they are, okay? I think this one's smaller. And let's look. If I did this with my fingers and I did this, you can see the red one is smaller than the blue one. So therefore, it is not an isometry, okay? And this last one looks like it is. I would say it is, and I would say it's a rotation, and it would be, if it's showing you the arrow this way, then it's a counterclockwise rotation, okay? So that talks a little bit about what these isometries are. If you have a transformation that is an isometry, they call them, they have a special name, they call them rigid transformations. So that includes rotations, that includes reflections, that includes translations. Okay, those are all examples of rigid transformations. All right, let's see what's next. Let's see what's next. So a little bit more in the way of notes. I don't know, I got a Teams meeting come up. Let's see if I can. I can balance that in such a way so you can see it. All right, so if they gave you some notation that looks like this, okay, the notation that looks like this, where they say triangle A, B, C, and they show you an arrow like that, and then they say D, E, F, they're saying, this is kind of like saying, is mapped to, okay, is mapped to, or is mapped onto, you could say to, okay, is mapped onto. Either of those are fine, okay? So that's just a little bit of notation. So we're gonna use this. We've got a little bit left. I'm hoping my battery space lasts. We have to. It says in the diagram, PQR is mapped onto XYZ. So PQR is mapped to XYZ. So that means the order is important. That means P matches up with X. That means Q matches up with Y, and it means R matches up with Z. Okay? Given that it's an isometry, find the length of XY and the measure of angle Z. So let's look. XY, what does it match? XY over here, that's first and second, matches PQ. So if I can find out what PQ is, then I can say what XY is. PQ over here is 3, so that means that XY has got to be 3. Now I want to find the measure of angle Z. Z matches up with R, so if I can tell what the measure of angle R is, then I know what the measure of angle Z is. The measure of angle Z is going to be the same as R, which is 35 degrees. Okay? All right. Good stuff, man, good stuff. So, one last question. So there are lots of transformations in real life objects, okay? You're gonna find that. You know, you haven't really started to think about these types of things, but you're gonna see lots of them. Okay, and here's an example. It looks like a railing, some sort of wood railing. It says it's from a porch. It says, how are pieces